Okay, just a quick little video. Show you what I'm looking for in terms of the reactions. So, for instance, if you get silver, if silver was one of your ions that you identified, then when you had your unknown, this, and you added hydrochloric acid to it, you must have got this. Okay, so if I had silver and added this, I must have got that. So I would write that equation like this. And you could sort of leave it as an ionic equation. So silver ions, they're all aqueous. Add in hydrochloric acid, which is also aqueous. And that'll yield silver chloride, solid, plus, so that's this, and then the hydrogen goes off by itself. And it'll be aqueous. So I want to make sure I account for all the substances are in there. Say another one. Say you got, what's the other one? Copper. So say you had copper. So copper, when you add this, nothing happens to it, right? So it's still in solution. But then when you add ammonium hydroxide, you get this deep blue color. So I want to write not this first reaction because nothing happened. I wanted to add this reaction to give me that. So for the copper, I would write something like this. So copper 2 plus, it's in solution. And then when I add ammonium hydroxide, also in solution, it produces, and just write that thing down there. So copper and an ammonia complex. Now that's sort of different, like in terms of single double replacement reaction, that's not one that I would have predicted. And there's lots of exceptions to our normal rules. But then I look back here and say, well, probably the only other thing that is left is that hydroxide. So maybe I'll just put a hydroxide here. Now this one was aqueous too. And hydroxide ion would be aqueous as well. Okay, and somewhere in your notes, just indicate that was blue, and that indicated the presence of copper. Let's try another one. Say you got, let me get rid of all this. Say you got calcium, okay? So say you got calcium right down there. So initially, here's calcium in my unknown solution number, whatever yours was. Added HCl, nothing happened to it. Added ammonium hydroxide, nothing happened to it. So the only reaction I want to see is when something happened. So if calcium is added to sodium hydroxide, I get this calcium hydroxide solid. So I want to see that. So for calcium, I'll do it in green. Calcium, I would probably say something like calcium 2 plus aqueous plus sodium hydroxide, also in solution, produces this calcium hydroxide, and it was a solid, okay, some kind of a precipitate, plus then you'd be left with sodium ions, also aqueous. Okay, hopefully you're sort of getting the idea of what you need to do for writing the equations. I'll maybe do one more. Let's do the iron one. Iron, we'll go red. So iron, let me erase stuff. Okay, gone. All right, iron. So iron is here. When you add hydrochloric acid, nothing happened to it, right? But when I added ammonium hydroxide, I got this iron hydroxide complex. Now that's probably the initial solid that forms. We did all these other steps here to confirm that presence of iron, but this initial one where you get that orangey kind of substance, I think I can use that for the reaction to indicate that you got some kind of precipitate. So for iron, I would write, it's a 3 plus. I would write something like Fe3 plus aqueous plus this stuff, ammonium hydroxide aqueous, yields iron hydroxide solid, iron 3 hydroxide solid. Plus, so if iron goes with that, then this must have gone off by itself, NH4 plus. And it might have reacted with something else, but the substance that I'm interested in is right there. That's a precipitate that I saw. Similarly with calcium, that cloudy kind of precipitate, or with copper, I saw that it turned blue, or with the silver chloride, I saw that nice white precipitate. All right, hopefully that helps you with writing out the equations.